The first disruption to equilibrium that we are going to cover is we're going to look at this example where we are going to take some iron thiocyanate with a +2 charge, and it's going to be in equilibrium with some species that has iron with a +3 charge, the cation, and thiocyanate SEN-. So a couple things that are going on here. First and foremost, this is called a net ionic equation. This is only showing the ions that are participating in this chemical process. So iron thiocyanate with a +2 is going to be in equilibrium with iron with a +3, thiocyanate with a -1. Now, what we're going to do with this simulation is we are going to change the equilibrium. We're going to do that by first putting in some more thiocyanate. So notice here, I'm going to add some SCN. So basically, I'm going to add some SCN on the product side of the reaction. This SCN here is going to go with this SCN here. And notice here that the sodium is not playing a role whatsoever because we call that a spectator ion, and it's not going to participate in the chemical reaction. So let's watch what happens. Here we've got our equilibrium solution. The dark red ones represent the iron thiocyanate with a +2. The yellow ones represent the irons with the +3s, and the white ones represent the thiocyanates, and that's the one we're going to add. So here we go, we're going to add it. The concentration of thiocyanate initially goes up, but over time, to compensate with adding to the right-hand side of the equation, I began to make more reactant. So if I added to the product side, that means that the concentration of the reactants went back up. It's just like a teeter-totter. If I push down on the teeter-totter, the other side of the teeter-totter wants to go back up to compensate for equilibrium. So if I added more product, I shift equilibrium back to the reactant side. This is actually the process that is used to do iron tests for people's blood. So if you were ever diagnosed as being a hemophiliac, you may have had a test where your blood was put into the presence of thiocyanate, and the concentration of the FeSCN2 that was registered would tell you your iron content in your blood. So now let's do something a little bit different. Let's, instead of adding something, let's take something away. And what we're going to take away is we're going to remove some of the Fe+3. So we're going to remove from the product side of the equation. You might guess if I remove from the product side, to compensate for that hole that's created where I lose those Fe+3 ions, that equilibrium is going to shift to the right-hand side, to the product side, to make up for what I lost. So let's see what happens here. So I'm going to take away some Fe+3, and lo and behold, the FeSCN decreased, and the amount of Fe+3 and SCN, or thiocyanate, increased to compensate for that loss. If we were to do this in a chemistry lab, what you are witnessing here is adding what we call oxalate to the system, and that's what takes away that iron +3 and shows you the color change where it goes from darker red to lighter yellow. So if I remove from one side, equilibrium will shift to replace from where I moved it from. Again, this is one of those labs that I really wish we were doing at school, because seeing this for yourself would make a lot more sense. But here are the 4 test tubes you would have created for this lab. And here's your original color. Here's one of the situations where we added product. And when I say we added product, we added to the right-hand side of this equation. When we added to the right-hand side of the equation, it shifted to the reactant side, or shifted left. Same part in test tube C here. We again added product, so equilibrium, to compensate for that, shifted left again because I added more to the right side, so the left side had to compensate. And then the last one, I added more reactant, and therefore the equilibrium shifted to the right. So I added more of this to get more of this. So that is what we have happening when we change the concentration of reactants and products.